The Fluke 1735 three-phase power logger is a valuable tool for analyzing voltage drops and other power quality issues in electrical systems. It's designed to record voltage, current, and other parameters over a period of time, providing detailed data that can be used to identify and diagnose problems. When dealing with voltage drops, it's essential to understand what causes them and how they impact electrical equipment. A voltage drop occurs when the voltage at the load is less than the voltage at the source. This can be caused by several factors, including firstly, excessive cable length, secondly, undersized conductors, and thirdly, high current draw. Excessive cable length increases the resistance of the circuit, leading to a greater voltage drop. Undersized conductors have a higher resistance per unit length compared to larger conductors, which exacerbates the voltage drop issue. High current draw, especially during motor starting or when multiple devices are operating simultaneously, can also contribute to voltage drops. The Fluke 1735 is designed to help you accurately measure and record these voltage fluctuations. The meter is capable of logging voltage on all three phases, as well as current, power, and other relevant parameters. This data is stored in the meter's internal memory and can be downloaded to a computer for further analysis. One of the key benefits of using the Fluke 1735 is its ability to capture transient voltage events, such as voltage sags and swells. These events can be difficult to detect with a standard multimeter, but they can have a significant impact on the performance and lifespan of electrical equipment. By recording these events, you can gain a better understanding of the power quality in your system and identify potential problems before they lead to equipment failures. The process of using the Fluke 1735 typically involves connecting the meter to the electrical system at the point where you want to measure voltage. The meter comes with voltage leads and current clamps that can be easily attached to conductors. Once the meter is connected, you can configure the logging parameters such as the recording interval and the duration of the test. The recording interval determines how frequently the meter takes measurements. A shorter recording interval will provide more detailed data, but it will also consume more memory. The duration of the test determines how long the meter will record data. Once the logging parameters are set, you can start the recording process. The meter will then begin to record voltage and other parameters at the specified intervals. After the test is complete, you can download the data to a computer using the Fluke software. This software allows you to view the data in graphical or tabular format, and you can also export the data to other applications for further analysis. When analyzing voltage drop data, it's important to compare the measured voltage to the nominal voltage of the system. The nominal voltage is the expected voltage under normal operating conditions. The National Electrical Code, or NEC, provides guidelines for acceptable voltage drop levels. The NEC recommends that the voltage drop on feeder conductors should not exceed 3% and the voltage drop on branch circuit conductors should not exceed 5%. These voltage drop limits are designed to ensure that electrical equipment operates properly and that there is no excessive heat buildup in conductors. If the measured voltage drop exceeds these limits, it may be necessary to take corrective action. This could involve increasing the size of the conductors, reducing the cable length, or reducing the load on the circuit. In addition to measuring voltage drop, the Fluke 1735 can also be used to measure other power quality parameters, such as harmonics. Harmonics are distortions in the voltage or current waveform that can be caused by nonlinear loads such as electronic ballasts and variable frequency drives. Harmonics can cause a variety of problems, including overheating of equipment, malfunctioning of electronic devices, and increased energy consumption. The Fluke 1735 can measure the total harmonic distortion, or THD, of the voltage and current waveforms. THD is a measure of the amount of harmonic content in the waveform. A high THD value indicates that there is a significant amount of harmonic distortion. If the THD is excessive, it may be necessary to install harmonic filters to reduce the harmonic content. The Fluke 1735 can also be used to measure power factor. Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a significant portion of the electrical power is being wasted. This wasted power can increase energy costs and reduce the capacity of the electrical system. The Fluke 1735 can measure the power factor of the system and identify potential problems. If the power factor is low, it may be necessary to install power factor correction capacitors to improve the power factor. The Fluke 1735 is a versatile tool that can be used for a wide range of power quality measurements. By using the meter to monitor voltage, current, harmonics, and power factor, you can gain a better understanding of the performance of your electrical system and identify potential problems before they lead to costly downtime or equipment failures. When using the Fluke 1735 or any other electrical test equipment, it is important to follow proper safety procedures. Always wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Before connecting the meter to the electrical system, make sure that the power is turned off and that the circuit is properly energized. Never work on live electrical circuits unless you are properly trained and qualified to do so. The Fluke 1735 three-phase power logger is a valuable asset for anyone involved in electrical maintenance, troubleshooting, or power quality analysis. Its ability to accurately record voltage, current, and other parameters over time makes it an indispensable tool for identifying and resolving electrical problems. By understanding how to use the Fluke 1735 and how to interpret the data it provides, you can ensure the reliable and efficient operation of your electrical systems. The Fluke 1735 measures volts, alternating current, volts, direct current, amps, alternating current, and amps, direct current. It can also measure frequency and power. Before using the meter, ensure that you are familiar with its operating manual and safety guidelines. Incorrect usage can lead to inaccurate readings or even electrical hazards. Always double-check your connections before energizing the circuit. When measuring voltage, be sure to select the appropriate voltage range on the meter. If you are unsure of the voltage level, start with the highest range and work your way down. This will prevent damage to the meter. When measuring current, use the appropriate current clamp for the expected current range. Do not exceed the maximum current rating of the clamp. Also, be aware of the potential for high fault currents in electrical systems. Fault currents can be many times higher than normal operating currents, and they can damage the meter or the circuit if proper precautions are not taken. If you suspect a fault condition, turn off the power to the circuit and investigate the problem before attempting to take any measurements. The Fluke 1735 is designed for use in a variety of electrical environments, but it is important to protect the meter from moisture, dust, and extreme temperatures. Store the meter in a dry, clean place when not in use. Regularly inspect the meter for any signs of damage, such as cracked cases or frayed leads. Replace any damaged components immediately. By following these safety guidelines and operating procedures, you can ensure the safe and accurate use of the Fluke 1735 three-phase power logger. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical safety. When using the Fluke 1735, it is also helpful to have a basic understanding of electrical theory. This will allow you to better interpret the data that the meter provides and to identify the root causes of electrical problems. For example, understanding Ohm's law, which states that voltage equals current times resistance, can help you to calculate voltage drops in a circuit. Similarly, understanding the relationship between power, voltage, and current can help you to determine the power consumption of electrical equipment. There are many resources available online and in libraries that can help you to learn more about electrical theory. Additionally, consider taking an electrical training course to gain a more in-depth understanding of electrical principles. The NEC is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years and contains detailed requirements for a wide range of electrical applications. The NEC covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians and other electrical professionals to be familiar with the NEC in order to ensure the safety of electrical systems. The NEC is available for purchase from the National Fire Protection Association, or NFPA. It is also available online through various subscription services. In addition to the NEC, there are other industry standards that may be relevant to your work. These standards may cover topics such as power quality, equipment performance, and safety procedures. Be sure to stay up to date on the latest industry standards in order to ensure that you are following best practices. Using the Fluke 1735 effectively requires a combination of technical knowledge, practical skills, and a commitment to safety. By following the guidelines and procedures outlined in this narration, you can maximize the value of this tool and ensure the reliable and efficient operation of your electrical systems. Remember that electrical work can be dangerous, and it is essential to prioritize safety at all times. If you are not comfortable working with electricity, consult with a qualified electrician.